Okay, so for our final project, we built a laser tag system. So
Okay,
go.
So our purpose is to build a laser tag system, improve the original design of the system, and determine the intensity of the laser at its farthest range, as well as the frequency of the speaker in the system. So this is what we used. First, some things that most of you know what they are, we just listed. So we used 5 10K ohm resistors, 2 5.6K ohm resistors, 3 47K ohm resistors, 2 LEDs, 1 9-volt battery, 1 breadboard, 5 1.5 volt batteries, 1 pager motor, a laser, and jumper wires. And some things you might not know about, we used 2 555 timing chips. They generate time delays or oscillations, and there are different terminals in them. I'm just going to explain it really briefly. They enter in the trigger, which is pin 2, and they go through this whole circuit inside this little tiny chip. And they come out through pin 3 in the output. That's basically all you need to know with them.
What's east for?
It helps with the time delay of the triggering, and then also the resetting. So when the photoresistor set off the speaker, and then the switch is turned off, it allows the circuit to reset.
We use 2 photoresistors. It loses its resistance when it's exposed to high levels of ultraviolet light. So when we shine the light at it, that's when the circuit it's closed. It's like a switch somewhat, kind of. They're made of cadmium sulfide and can be mixed with impurities to allow lower frequencies of light to trigger the device. That's basically all you need to know about them. You can read the description further if you like. We used a 5mm tactile switch, which is just a switch, and it has 4 pins, and it's to reset the circuit after the LED goes off. We used 1.01 microfarad capacitor, which you all know what capacitors do. And we used a piezoelectric speaker, which is a speaker that has a positive and negative end, and that's pretty much all you need to know about it.
Well, there's ceramic plates that vibrate.
Yeah. It makes a noise at a certain frequency depending on the resistance of the circuit that it's in.
Alright. Steps we took to build the receiver.
You wrote this up, so go for it.
Okay. So first we put the 555 timer chips in. Well, you can see it there, and basically put them in where they are. Then we add a 10 ohm resistor here, and we put the tactile switch in.
Oh no!
What did I do?
Oh.
I apologize.
Who touched it?
Oh.
No.
I'm just gonna hide now.
See what I told you? See what I told you already?
Wow, wow. Let's not go there.
We won't judge you. No, you guys are doing fine. It's just on.
Okay. Yeah, we were. So next one. Yeah. Next we added the photoresistors to where they are, and then we basically connected stuff with jumper wires. Then we added more resistors to, I believe, here and then over there. I think
There's 3 of them.
that might have been a bit. Then we added more jumper wires, and we put this is the piezo other thing. then we added more jumper wires.
Lots of connections.
Yep, and then we added the capacitor here. And an LED too.
We added so many resistors because
Yeah.
if there wasn't that much resistance, this current would go right through the LED and not light it up. So
We also ran into a problem where with the resistance, it created a frequency in the buzzer that was inaudible, so we couldn't actually hear it go off, even though it technically was working. So the instructions that we used said to use 65K ohms. We couldn't find those. We had 47K, so we added in
10K.
total of 15.6 K ohm resistors in series with 47K, and so that brought it up to 62.6.
Yeah.
Okay, so it was a little off, but you can
Close
still
enough.
hear it.
Close enough
Still
for it to
works.
function.
So then we put in, this is another resistor
Yeah,
we added.
that's just what we
And
explained.
then we put the power attached there. And then there you go.
Alright, this is just, it's a lot of text, but just how the circuit functions is there's two parts, the bistable multivibrator, which is just the triggering part of the circuit that has the photoresistors, and basically with the 555 timer chip, once the voltage at pin 3 is 3 volts, it allows the other chip to work at that voltage, and that's basically all you need to know. And then for the second part, it's called an A-stable multivibrator, and this just generates the wave tone in the piezoelectric speaker, and then the tone is determined by the 65K ohm resistors, or in our case, the combinations of the resistors that we use to replace that, and the microfarad capacitor, and we'll get into more of how that frequency is generated and what we did with the frequency that we measured.
This is how we built our laser gun part. This was fairly simple, but originally we had a series circuit with a battery, which we used 9 volts, connected to the laser, which acted as our switch, and then it connected to the pager motor, and then back to the battery. But we found out that we burnt out the laser after 2 days because we were running so much voltage through it, and the laser needed less voltage than the motor. So then we tried running a parallel circuit with the motor with an extra battery in parallel in the series circuit, but it didn't work because the motor just went off all the time with that. So now we have the battery connected to the pager motor, and that's connected to the laser, so the motor gets more voltage than the laser, and then it connects back to the battery. And we played with the voltage, and we found that because we had a bunch of 1.5 volt batteries, we used those in combinations to find the lowest voltage that was able to run everything together, and so that it wouldn't burn out the entire circuit. So we found that 7.5 volts was the voltage that we used. And this is our schematic diagrams.
You can explain all that.
Okay.
Really complicated.
This is the battery, and it goes through these resistors. This is the 555 timer, but it's just a blown up schematic of it, and this shows all the outputs and inputs. And then it goes to the switch, which is the laser, and this is the photoresistors. Or not the laser, that's the switch. It's just the switch. Sorry, I'm getting these confused. And then this is the photoresistors, another resistor. These are the 555 timers again, but this is just the same thing as that. And then this is the piezoelectric buzzer capacitors. These are when we had to add the resistors to add up to the 62 ohm resistors, K ohm resistors. And then back to the timer, to the LED, and back to the battery. And then this is the really easy laser gun thing, which is just a series circuit.
Okay, so as far as the experiments, the first test we did was the minimum intensity. Unfortunately, we could not test the exact range because of due to weather, like the last few days, and the length of the hallway wasn't long enough to get the full range.
And
so
the length of the hallway is 310 feet, by the way.
yeah, so
So it goes over.
it reaches over 310 feet. But basically what we did is, since the laser range that's on the package said it reaches 500 feet, so we just used that distance. And then basically all we did was we took the light sensor and hooked it up to Logger Pro, stand 20 feet from the light sensor, and then measure the intensity of the light there. So you can see the peaks. Those are when the laser was just dead on to the sensor, and then we used those as our intensity values, and they all turned out to be 8,349 lux, which is the unit for intensity. And then since the intensity over distance behaves as an inverse square law, we could determine the intensity. We could calculate the intensity at 500 feet, and once we calculated that out, it was 13.35 lux. So that's based on the information by the package, what the minimum intensity would be to set off the receiver. And just basically errors with that is the range stated may not be exact, obviously, so we had no control over that. And the experimental range, like we said, was not determined, and that would have been a lot better indicator of the minimum intensity, but unfortunately we couldn't because of weather. So we were going to go out at night, but it was raining. And then the second test we decided to throw in, which is the frequency of the receiver compared to the calculated, which we can, here at the bottom you can see and this was from the instructions of the entire laser tag system, so you just plug in the values of like normally in there you put the 65K, but in ours we put in the combination. And basically all we did was just use the microphone hooked up to Logger Pro and record the sound, and then what you have to do is insert the FFT graph, which gives you it's kind of hard to see, but it gives you the frequency versus amplitude. So this is the frequency that was of the sound from the receiver. And then, and then basically what we got was 2,562.64 hertz. And then versus the calculated, when we plug in the values of our resistors, was 838. So obviously there was some error going on here. You can do this one. Basically, one of the main things was that there was a lot of since the resistors were so packed together tightly, there was some short circuiting going on. So that would reduce the overall resistance of the circuit and then increase the output frequency from, you can see the relationship in the equation. And then also the resistances aren't exactly as shown the 65K. They're usually within, I don't know what the
5%.
Yeah, so that could also play a part of it. All right.
Okay, some of this is experimental error, some of it is information that we'd want to remember if we were to ever build a system again. Because while we were building the system, we ran into a few problems that probably should have been prevented. So the first one is make sure the current runs in the correct direction, because we found that if especially with the piezoelectric buzzer, if it wasn't connected in the proper direction in the circuit, then it wouldn't work at all. And also same with the LEDs, but that's not as much of a concern. Also, we have to make sure that this was used in a dark environment, because we ran into the problem where we were testing it and it was working, but it wasn't going off. And we figured out that it was because the light was setting off the photoresistors enough that it would allow the current through. Another way this can be prevented is using a photoresistor with a greater resistance, because ours were about 1K of resistance, and the recommended amount is like 3.6 M resistance. So yeah, mega ohms.
But we couldn't find them.
Yeah, we couldn't find those. So we managed, but it would be better to use a greater resistance. Also try to, as Katie was saying, space out the resistors as much as possible, because if the wires are touching one another, it could short circuit. Also, use a battery with a voltage of about 5 volts. As Megan was saying earlier, at first we used one with 9 volts, but we burnt out multiple LEDs, and we
burnt out 3 lasers.
Yeah. So we ended up, the little 1.5 volt batteries, we ended up taping those together, and so we got a voltage of 7.5. 7.5. So that worked, but it would be better to try to find a battery that was closer to 5 volts. Also, try to use 65k ohm resistors. We couldn't find those; they weren't available. The largest was 47k ohms. So, as we said before, we put other resistors in series to bring it up to 62.6k ohm of resistance. But that was still slightly too low and allowed more current through, so it did affect the frequency of the piezoelectric buzzer, although our system is functional. What?
Also, we found out yesterday that you cannot use Gorilla Tape as electrical tape.
No.
Because the glue interferes with the reaction, or the connection between the metal parts. Mistake. Also, for our laser gun, because we couldn't use the 9-volt battery, which is just one battery and it has clips that you can add onto the end of it, we had to basically tape wires to the ends of the battery, and there wasn't a holder small enough for it. So this is just a prototype, but when you use the gun, if you want the motor to also work with the light, then you have to hold the ends of the battery like this and then press the button. So those are just some errors we ran into. Because it was our first time making this.
And those are some.
And we made
Nice
straps so you could strap it on your body.
Alright.
And
So
we
you can
made
go down the
a lever arm so you can hold this in your hand.
So,
We
if you guys would like, we could go out in the hallway and do a brief demonstration. Or
right here if you
or right here. Oh, yeah.
The lights are on in the hallway. It actually works in the hallway.
Yeah,
Not too intense.
Also, we found that if you like kind of shield it a little bit and don't let the light hit the photoresist directly, it works.
Mr. Murphy, you can Christina, I'll go in there.
Is it?
Ready? That's it.
Yeah.
Nice.
Anyone want to try?
Does anyone want to try it?
Does the laser still vibrate? Or-
Yep.
Cool.
As long as you hold the ends of the battery.
It's a safety feature.
Yeah, right.
Yeah.
Very cool.
Alright.
Join us.